So, what's up, guys, and welcome back. So, we are going to start the model evaluation. We're going to start developing the model evaluation. In the previous video or in the previous session, we dealt with the model trainer. So by in that video you saw how we can train the model. So we imported the test data and the test data extend transformed and the way train, and we did fit our model onto the training data. And after that, we were able to save our model. And when you looked at the artifacts model trainer, you saw that the model.joblib. So that was our model. So basically, under that, you saw how we can train our model on the testing data. So we are going to do a model evaluation to see how our model is generalizing on unseen data. Okay, so we are going to start on that. So as usual, we are going to go to the config.yaml, and under the config.yaml, we are going to create a new stage, and this stage will be on model evaluation. So model evaluation. So under model evaluation, again, we are going to specify the root directory, artifacts model evaluation. Then we're just going to paste some other information. The test data path, we need to specify the test data path where we are going to sort or look for our test data. So test data in terms of the features. So this is the path. Test target variable. So the target variable for the test data. So the y-test data. Remember in the data transformation, we split our data into the training and the testing set, and we saved our test set. So our test set is in this folder. Okay. So the model path. So in our model trainer, we were able to save our model. So the model.joblib. So this is the path for that. So we'll be using this to sort of import the model into when we are doing the model evaluation. Then we are going to save a metrics.file, metrics.json, where we are going to save the values of the values of after doing the evaluation. So for example, the mean absolute error, the R squared score, all that, we will be saving that in a file under the name metrics.json, and this will be the file path. So we have successfully updated the config.yaml. So we go to our model evaluation and start building that. So under the model evaluation, again, we are going to start. Under this model evaluation, remember, we are going to integrate the MLFlow. So let's start building let's start by the usual way. So we just build our entity configuration. Then after that, we can integrate the MLFlow. So as usual, we are going to start with the entity. So I think by now you understand these steps. So there's no need of stressing them. Okay, so then after that, we're going to import the config file path. So from src root battery dot constants. We're going to import these files from constants, and also we need to import some functions from utils. So from src root battery, we are going to import these files from utils. Sorry, these are functions. Then we create our config. Let me just copy that. So this is the configuration manager for that. Here we are creating model evaluation config. Then we are specifying this. So the object for this will be, so we are going to return, we're supposed to close this bracket, close, so we're going to close. Then we return model evaluation config. Yeah, that's okay. Then after this, the only thing that remains is creating. So we create a class, a model evaluation class. So this is the class that actually handles the model evaluation. This will come. I'll show you the MLFlow part. Let's complete the common tasks. So model evaluation, then we do our predictions. So the prediction, we need our model. So you know where we have saved our model, and we need the X test transformed, and we also need the Y test. So we do the predictions on the X test. Okay. Then after that, we can do the model evaluation, and under the model evaluation, remember we need the X test as well as the predictions. So under the evaluation metrics, we are doing the mean absolute error. So mean absolute error, the Y test and the Y pred, the mean squared error, the R squared the score, root mean squared error, as well as the mean absolute percent error. So these are the different evaluation metrics that we are considering in our model. So after we have completed with the model evaluation, then the next step will be about saving the results. Okay, so we can save the results. So remember, we created that file, the metrics.json file. So results we're going to save in a JSON file, and these are the results. So we're just trying to in the return we remember we use the Y pred. So when we are going to save our results, we don't need that one. So we are going to exclude the Y pred. Then we save our metrics. Okay. Then after this, we will then save our pipeline. Create our pipeline. Then we can create our pipeline. So this is our pipeline for that. Okay. So with this, I think we are done with the model evaluation. So remember, we started with our entity. Entity, we specify the root directory for creating the we're creating the folder for the evaluation metrics, where we will be storing the necessary output files from the model evaluation. Then we created our configuration manager for that. Then after that, we created the class model evaluation that will actually do the model evaluation. And in the model evaluation, we are making predictions on the unseen data. Then from that, we can do the model evaluation, where we compare what was predicted and the ground values, the ground truth values. So in terms of evaluation metrics, so these are the evaluation metrics that we are doing. Then after that, we are going to save our results, then create this pipeline. Okay. So remember, this section we need to also integrate our MLFlow. But let's execute this to see if it is running. Then we convert this to the modular coding. Then after that, we integrate the MLFlow. I think that step is necessary. We need to ensure that our code is running okay. Then we can integrate the MLFlow that will help us in experiment tracking. So let's execute this. Copy relative path. So Python. This one was just short. It wasn't something very lengthy. So we are going to execute this, ensure that our code is running okay. Then after this, I think we don't need to convert to modular coding. We just infuse the MLFlow, then copy the necessary sections into their respective files in the SRC folder. Then I think from there we will be done with the model evaluation, and you will be able to track the experiments. Okay, so this is all about the model evaluation. So you can see we are creating the model evaluation file, the metrics.json file, and you can see the different metrics. So we have the mean absolute error, the mean squared error. These are the values: the R squared value, the root mean squared error, and the mean absolute percent error. So you can see that our model is performing quite well. Okay, so based on this, the mean absolute error, you can see it's quite small. Mean squared error, again, generally you can say that our model is performing quite well. So from here, we need now to integrate the MLFlow, and I'm going to show you how. So the first thing that we need to do, I'm going to use the Dagshub. So you need to first, if you don't have an account with the Dagshub, so you first create an account with the Dagshub. Then from there, after creating an account, you will come to sort of a page. So as you can see, I've done a lot of experiments. So that shouldn't concern you at the moment. So what we need to do is remember this is our GitHub Git repository. So we need to sort of merge this Git repository to the one with the Dagshub. So to do that, we need just go to this new button, so new repository. Then we're not creating a blank repository. You're just going to connect a repository with an external source from GitHub. So you click on this, then connect with the GitHub. With the GitHub, then we need to we need to choose add or revoke access to a repository. Then from here, you'll be sent to Git. So you need to authenticate. So I'll use a passkey so that we're able to link the Dagshub to the Git repo. So remember that this is the repository. So I'm just going to copy that, and then I'll just select a repository. Only select. So we are going to select a specific repository. So I'm just going to search the repository battery rule. So I think it's this one. So click on that, then you just save. So after you save that, so you'll be taken back to Dagshub. Then you will see your repository. So you click on that, then you just do connect. Click the button connect repository. So after that, you'll be taken to such a page. So you can see this is don't need this at the moment. So you'll be taken to such a page, and then you can see that technically you have done something like cloning your repository from GitHub to Dagshub. So from here, you just go to this button remote, then you go to experiments. So under experiments, you remember this is what we will be using. So this is the ML4 tracking think something like a link, and we need to copy this information into our model evaluation script. Okay, so I think by now you understand. By following the step-by-step sequence, you are able to follow this and understand how we are going to integrate the model MLFlow. So from here, so remember we are going to copy this to our script. So we are dealing with the model evaluation script. So let's go to the model evaluation, and we need to integrate that. So the first thing under model evaluation, so what we will do is copy that. So I'm going to copy those files here. So the first thing that I'm going to do, I'll import Dagshub. So import Dagshub. That's okay. Then I'm going to import MLFlow. So import Dagshub, import MLFlow. So we need to copy, I think we need to copy this file here. So Dagshub.init repo, so this one here. So I'll copy this and go back to my code, MLFlow, then copy the Dagshub init repo mini code. Okay, so that's okay. We also need to copy MLFlow set tracking URL. So the tracking URL, need to copy that. So the tracking URL, set tracking URI. So this is the URL tracking this URI. I'm going to copy this, and we are going to create so MLFlow dot set tracking URI, and I'll just paste that here. So this is this value here. So go to ML. So if you want more information about what we have just done, there is somewhere you can additional help. Then from the additional help, I think from here you can follow through. So remember we installed our MLFlow library. Then this one here, set the Dagshub as a remote URI. You can set the MLFlow, this one here. So MLFlow set tracking URI. Then we copied that tracking thing, this one here, tracking remote tracking link, this one here. So I think we are okay up to there. This is all about if you want to, this one, if you want to set MLFlow with the S3 bucket from AWS, but we are not going to do that for this analysis or for this section. It will come later, but at the moment I think we are done. We have done this, and I think we are also completed this. So set up your credentials. The Dagshub MLFlow server has built-in access control. Only a repository contributor can log experiments. Someone who can git push the repository. So in order to use basic authentication with MLFlow, you need to set the following environmental variables. So we also need to do this. I think we're supposed to run this in our terminal. So MLFlow tracking username and MLFlow tracking password or token. So we need to set that. So MLFlow, we need to copy this. So I'll just copy. Let's copy this first. So let's copy this first. And I'll go to my code. Then from here, we can set this in our setup.yaml readmd, and I can just set this here. Export MLFlow tracking username. So we need to fetch for that. Tracking username. So Dagshub username. So MLFlow tracking username, Dagshub username. So my Dagshub username, you are setting your profile. I think this is my username, if I'm not wrong. So my username. So I'll just go back to my code. My username, my.txt. We need the readmd. So my username is this. Then password has /token. Let me specify that. So username is this one. So we need to set the password for the token. So token, you can go to settings, password. You need to set your password or create access a token for Dagshub. So I'm going to create an access token. So the token you're just going to, so remember password, then create an access token. Then you can think your token is already created. So you can supply, I think this token is auto-generated on sign up. So this is default access token, allows you to access the Dagshub API without using username and password. You can also supply them instead to you can also supply them instead of the username when performing the Git DVC or MLFlow operations, and they will work without needing to supply the password. So this is especially recommended in automated environments. So you can just see that. So I think it's already generated. I'm just going to copy that, then go back to my the code. I think my token is this. And then we need to execute this in our terminal. So I'm going to copy this, go to my terminal. Now we execute this. It is not recognized. So I think here we can use the git bash. So git bash will work well. We need to execute this. Okay, so that's it. So we need to this one here. I don't know. Let's try the bash export Unicode is not a valid identifier. So let's try and see. There's something I'm missing, so let's find out. So what we were missing is we needed to include the MLFlow tracking URI. We also need to include the username as well as the tracking password. I have shown you where we can get this. For the URI, this is the tracking URI. So you can just copy this, and then in your just a minute, in the export MLFlow tracking URI, then you can just paste it here. For the tracking username, again, if you want your username, can you go to settings? Under settings, you can see this is your username. So you can just copy that, and then go to your MLFlow tracking username. Copy the Munich code. This is my username, so you copy yours. Then in terms of the password, again, you can just go to the password. Then from here, you generate your own, create your own access token. Then after that, what you need to do is you need to execute this in your terminal. So for my case, I've executed this in my terminal. So this is the URI. Okay, this is for the username, and this is for the, I think this one is for the password. Okay, so after executing this, and then we can go back to our code itself, and then from here we are going to now integrate. We are going to integrate now the MLFlow. So we have added imported Dagshub MLFlow. So we have specified this. So repo owner, this is the repo owner, repo name, MLflow true, MLflow tracking URI is this one. So after that, so under the data class, we need to add the MLflow component. So for the MLflow, we are going to add MLflow. So from here, we can say MLflow URI. So this will be a string. So MLflow URI string. Then we are going to specify that under our config. Okay, so after target column, we need to add that. So MLflow URI. We are going to specify this as this is the URI that we are going to use. So the tracking URI. So I'm just going to copy that. Then MLflow URI, and then we are going to specify that here. So you can include a quotation mark. I think that one is okay. So MLflow, then I can just use a comment here to specify that this is where MLflow, this is where we include the MLflow. Then we need to import these libraries. So when we are doing the model evaluation class, the class that actually does the model, where we are going to implement the model evaluation. So we need to import the URL library. So this library enables us to read this URI. Then we import the MLflow.sklearn. Okay. Then after this, we need to implement or add the MLflow setup. So after we are done with this, we are going to import the tracking itself, where we are going to track our experiments. So after this, we need to import this. So from here, we are creating a method to log in into MLflow. So we are loading the trained model, transform test data, and the y-test. So basically what we were doing previously. So model.joblib. So this is how we are loading the trained model, transform the test data, as well as the y-test data. So we are loading that. Then after that, we are going to make predictions. We are making predictions using our model, and the x-tests are transformed. Then we are going to evaluate the log metrics. So here, remember, earlier on we were returning this, but we don't need the y-pred. So we are just using that underscore here, but we need to track these metrics. So we are going to log and track the mean absolute error, the mean squared error, the R squared value, the root mean squared, as well as the mean absolute percent error. And we're doing the model evaluation. Remember, we are using the y-pred, what the model has predicted, and we are comparing that with the true values. Okay. Then we set the MLflow setup. So the MLflow tracking URI. So this one is going to link with this. Then from here, we are going to input this value. Okay, so that's the URI tracking value. Then tracking URI type store. So we are using the URL pass. So this one is why we imported this library, so that we are able to read the URI value. Okay. Then from here, then this one, we are able to now get the results in the registry. Then after we are executing our MLflow, then after this we need to end the existing run. So if you have an initial MLflow run, before we execute a new run, we need to end the previous one. So that's why we are including this value. Then from here, we are using with MLflow start run. So this will start after exiting the previous run. We are going to initiate a new run. So we're starting with this. Then we log the parameters that we have specified here. I think this one here. Then log the metrics. Logging is just copy that metric in the MLFlow. So we are logging that into that library. So here, if the log model for the model registry, if the tracking URL type pass is not in the file, then we are going to log this, else MLFlow log model. Okay, so from here, I think we can maybe try to offer an explanation as to what we are doing with this. So again, the selected code snippet is part of the model evaluation class, which is responsible for evaluating the trained model, learning model, and logging the results to MLFlow. Okay, so log MLFlow, this is the method that we are creating. And inside the method, we are the training model. So we are loading the trained model, all that. So up to here, we again think evaluate the log metrics. So evaluate model evaluation. So I think y test y pred, this one here, model evaluation. Then after that, MLFlow URI is set up by calling the set tracking URI with the provided MLFlow URI. The tracking URL for the registry is obtained by using the URL pass. So this one here. So you understand why we are using that. Then before we start a new run, we need to end the previous one. Any existing MLFlow run is ended using this. Then a new MLFlow is run. New MLFlow run is started using this line of code here. Then from here we log the parameters attribute of the model evaluation config. So this one here. So we log all params here. So all params, we specified all parameters in the params.yaml file. So we are logging those parameters. Then after that, the model parameters are logged into the MLFlow log params with the all params attribute in the model evaluation config. So I think you understand that. Then the evaluation metric, this one here, are logged using the MLFlow.log metric. So evaluation metrics, we are using the log metric. This one is for the parameters. This one is for the evaluation metric itself. Then depending on the tracking URL scheme, the model is logged for the model registry using the MLFlow sklearn.log model with the model name. So with the model itself, the model name, and the registered model name, which is the XGB regressor. If the tracking URL scheme is file, the model is logged without registering it. So with this, we can see or demonstrate how to evaluate a machine learning model, log the evaluation metrics, log the trained model, and the MLFlow for model registry. So essentially, we'll be tracking our experiments and also register our model. All those information, we are going to do that. So since we have done with that, we need to change our pipeline, just tweak it a little bit. So instead of this, we are going to change that now to something else. So our new pipeline will be something a little bit shorter than previous one. So this will be now our pipeline. Okay. So let's execute this and see what value we'll be getting. So that's how we can integrate MLFlow. So just remember the steps that we took up to this step. So we are going to execute this script. Then now we will see the values. It's supposed to be no value Dagshub. No module named Dagshub. So do we need? Let's see here. Pip install Dagshub. Pip install Dagshub. Maybe we didn't. Let's see, in our requirements.txt, I think we did not include that one here. So I think Dagshub. also require that. Okay. So here you can see when that is done, I think we're missing the Dagshub library, Dagshub. You can see it's an important library that we didn't include when we were executing when you are downloading and installing the other libraries. So I think this one I won't be using the DVC. So there's another project that I'm preparing. After this, I'm going to launch another project that will be a classification problem. So in that classification problem, again, I'm going deeper into. So we started. Now as you can see, we are going deeper and deeper, and in every project we are trying to implement a new tool. So I think in that project, it will be a classification problem, and in that project, we are going to implement the DVC. So you can see how we can track our data and possibly the different pipelines. So in that, and that's when we'll use both the MLFlow. You can also include the DVC to have a feel of how we can use those tools. So that's just as a little bit sneak peek of what we will be doing in the next series. So I think right now everything is okay. So you can maybe use a new terminal. Model evaluation, you can maybe model evaluation, pull it back. So I don't know why we are having a challenge here. Checking for quick fixes. I think we have installed the Dagshub. We will be seeing this problem. Let's see, Python copy relative path. No, it's supposed to be relative path. Then let's see, we need to installing the library. I think it should now execute. So if it executes successfully, we'll go back to our Dagshub and you'll be able to see the metrics, possibly the model, the metrics, and the I think the logs, the metrics themselves. You will also see those in the MLFlow registry. So let's see if this one is going to be successful. So if it executes, then we are good to go. So also this MLFlow, you can also use the MLFlow for model trainer. Now you can see it's now working. We are able to track the repository. Repository mean code battery rule initialize. So I think we are on the right track. So what I was as this is loading. So what I was saying, I think also in the next project we will also track the model training. We will track the model evaluation, and I'll also introduce another component which is also very important in machine learning, which is about model validation. So we'll have the model trainer track the metrics for that, model evaluation track the metrics for that, and the model validation also track the metrics for that. So we'll see how we integrate that into our into the working. And as I said, that will be a classification example. So it will be quite wide, wide. So stay tuned for that. I think this one is now okay. So it's just going to take some time. Then from there, I think we will be okay. So from here, I'll show you how we can that's model evaluation. I think we are in the model evaluation. So just be patient and give it a little bit of time. So this is MLFlow. Know why it's taking quite some time. Let's see if maybe in our Dagshub we're supposed to go back to our code and see if now we can see we have successfully registered the XGB regressor as a model. Then info ML store model registry abstract store waiting for 300 seconds. So created a version 1 for the model. So let's go to our Dagshub and see how we have tracking our experiment. So we can see under experiments, let's see. So it's taking some time, but we need just to be a little okay. Now I think it's okay. Experiment, you can now see 3. So this is our experiment. So when you click on this, you can now see these are the parameters. These are now the parameters you can see: booster, full sample, gamma, learning rate. Okay, you can see these are the metrics, and for the metrics you can also see the different the metrics for that. Okay, so these metrics, if you compare them, they should be the same metrics as the ones that we were getting from the metrics.json file. So I think they should be my 2.45. It should be mean absolute error 2.45. Yeah, so that's it. Okay, then in terms of the model, we are also doing the model registry. I think we should be getting our model under this section. So this is the model, and you can see this is the model, and this is the version 1 of the model. So let's try something different. Let's go to our params.yaml. So schema params.yaml, and let's try to params.yaml. Let's try to change a value here. So for example, let's say we use a learning rate of 0.3. Let's say 0.5. Okay, and also use can also change another metric. Let's change subsample rate, let's say 0.5. Okay, let's save this and then go to our model model trainer, then model evaluation. So let's go to a model trainer and model trainer. So I'll just copy the relative path. So again, Python. So we train our model with the new hyperparameters. Then we also do the model evaluation. And since you have changed the parameters, you will see a slight change you'll also see a slight change in the metrics. So you're able to compare. Picture that the previous one as our experiment number 1. So whatever we are going to do is an experiment number 2. Okay. So having changed the values of the parameters, possibly there will be a slight change in the evaluation metrics. So after this, we need to run the model evaluation. So again, I'm going to copy relative path. So we can say Python model evaluation. Okay. So from there, if this again runs successful, then we'll see a slight change in our experiment. Then from there, you are able to possibly compare the different experiments to see which one is better. Okay. So let's wait for this to execute. Then from here, we go to our Dagshub and try to see if we compare the two experiments. So experiment 1 is then experiment 2. Okay. So this one is okay. So I think you have up to now you have a slight, or you have a general knowledge of how you can implement MLFlow. So there are different tracking tools, but for these projects, what I essentially preferred is to use the open source tools. So we just learn how to use these open source tools, familiarize with them, know the ins and outs of these tools, then they will be of great help. So even if you encounter, or if you're going to work somewhere, you encounter or work in companies that they have their own systems, then just transferring this similar knowledge or a similar understanding from the open source tools, what they are using, it will be quite easy. Okay? So it's better to use these tools, understand most of them, then it will be good for you. So you can see we now created version 2 of the model. So I'm just going back to, let's compare the experiments. So you can see now we are at the experiment number 4. So with the experiment number 4, for example, if I want to compare the two experiments, so I'm going to click experiment 3. I think this one is 3 and 4. So 3 and 4. Then we do some comparison of those experiments. So experiment 4 a minute ago and 9 minutes ago. So this is experiment 1 and this is experiment number 2. So yeah, can compare now the mean experiment 2. You can see 2.6, 2.4. So you can now compare the two experiments. Mean absolute percent error 2.18, 1.5. So you can see just a slight change in the hyperparameters. You are getting quite a huge change in the metrics values. So if you are using, for example, the hyperparameter tuning, so after tuning a model, you can just go to those parameters, just change those values. And when you change those values, you can run the experiment again and do that comparison. Okay. So now you can see how the different experiments are working. So you can now see the slight change from experiment 1 and experiment 2. Okay. So for the model itself, again, you can, I think, if you can compare the version 1 and the version 2. So this one is the version 2. Version 2. Filter registered models. This is the version 2. I think the version 1 and version 2. So version 1, version 2. That's it. So this is how you can use MLflow in integrate MLflow in your analysis. And you can see MLflow is very important because you're able to track your experiments. You're able to track experiments, able to compare the different runs of experiments to find out which experiment is working quite well. Okay, so even with the after we change those values, then you can just come here. Then earlier on we were using what were you using? So let me go back to anyway, there's no need. So I wanted to change my parameters, but there's no need. There's no need. I think you just have an understanding of how you can integrate these tools. So before we end the session, let me convert this code into sort the components, the entity into their respective files under the SRC folder. Then we can push this code into the Git repo. So from there, you can now have have a look at it. If you find something more information, or if you want to add something on this, then you can add from there. This is just the basic understanding or the base knowledge about the MLflow, but possibly you can do a lot of things with MLflow. So if you go to the MLflow website, so from here you can learn more about MLflow. Okay, so you can see the different techniques that you can use. You can compare experiments, you can optimize, and all that information you can get from MLflow. From where releases, I think the documentation, if I'm not wrong, from the this is the documentation of the MLflow. So you can spend some time, read through, understand, see how you can implement this. Then I think with the subsequent projects, we go deeper into MLflow, see how we can use the MLflow in our experiments. Okay, but at the moment, let me convert this code to a modular code. So we start with the param entity. So we start with our entity. So I'm just going to copy this. We go to our entity, config entity. And this one was the model trainer. So model trainer. This will be model evaluation. Model evaluation. Then I can just copy this, paste it here. That's the entity. So we go to config, configuration.py. So under config, we go to our model evaluation. So we can copy this one here, get model evaluation config. So configuration, this was the model trainer. So after model trainer, we go, or I can just copy this first, then I can get here model evaluation config. Okay, so then I make sure you import this library. So model trainer, comma, model evaluation config. So are we missing anything? MLFlow URI, everything I think is okay. Yes, so yeah. So after this, we go to our components. So component, model evaluation component. I think we don't need this one. Again, we don't need this. So model evaluation. So for the model evaluation, I'll copy this up to MLFlow. I think this one is okay. Then model component number, yeah, model evaluation. So with the necessary files, so we need to import this from entity, if I'm not wrong. The evaluation config. So again, from src dot rulebetsy dot entity dot config entity dot model evaluation config. Model evaluation config. Are we missing anything? Let's cross check. Save JSON and path. We also need the path lib. So we also need the path lib, and we also need from utils. From utils, from src dot rulebetsy dot utils, we're going to import. It's supposed to be commons. Dot commons. We're going to import. Going to import what save JSON. Save JSON file. So we yeah, I think we are okay with that. Everything is okay at this moment. So we are not missing something, or we have not left out something. I think we are okay with this. So after model evaluation, we need to go to the pipeline. Model evaluation pipeline. For me, I'll just copy this, but I need to change something. Just copy this. Pipeline. So pipeline name, the usual stuff. So after here, dev run, that's okay. And when we go to our model evaluation, this is the pipeline. So we can just copy this model evaluation. So that's okay. So we need to copy MLFlow, import MLFlow library. So MLFlow library, this one here. So just copy that, and after this, you can import the MLFlow. So yeah, that's okay. Then now we end with the if. Yeah, it's supposed, instead of main, supposed to be run. We are running the pipeline, model evaluation pipeline. Yeah, this one here, model evaluation pipeline dot run, terminate successfully. That's okay. So after this, we end now with the main.py. So main.py. So main.py, we are dealing with the model evaluation component. So model main.py, model evaluation component number 5, model evaluation. So we need to import the model evaluation pipeline. So again, I think this is, yeah, 05 model evaluation. Yeah, I think everything is okay. It's supposed to be run. Model number 5. So let's execute. So Python main.py. So let me do this. The params.yaml. Let's create another. Let's create another experiment, and from here we changed. Let's compare. So this one was the earlier one. So we can say learning rate was 0.3. So learning rate, let's convert back to 0.3. And I think subsample, I think it was 0.5. So let's see. Subsample is supposed to be 0.8. Subsample is supposed to be 0.8. So when we execute the Python main.py, so when we execute this, we are going to have another the third experiment. So again, we can think as of now everything is okay. So we don't need to panic. We can just do away with these params. Away main.py, we need it. Evaluation, save it, and just to make our workspace tidy. Main.py, execute. So in the next project, you'll see the usefulness of using DVC. You see, right now we have a challenge because we are not tracking our the pipelines. So when we execute, for example, the main.py, it's going to execute everything from the beginning. Okay. So we start with the data ingestion, data validation, data transformation, all the way until a model evaluation, which is taking quite some time. But if you are going to use the DVC to track our experiments, then it's going to skip these steps if there is no change in data or the code itself or anything along that line. So we are having an issue. So MLFlow API the issue with the start and the end run. Go to our components, model evaluation, model trainer. Supposed to now we need to end the run. An issue. Track components terminate successfully. Do we need this one? Maybe. Let's see. Then let's execute the if there's a problem, I'll just work it out. Then before we start our model validation, then I will make sure to inform you on how I sorted the problem. Then from there we can continue from there. So I'll work on that issue that we are facing. But in the meantime, okay, even the experiment is not showing. So I'll work on that problem. Then in the next session, when we start maybe constructing the prediction pipeline, the app.py, all those, then from there, I'll inform you on how we can correct this, then proceed from there. But all in all, I think by now you have an understanding as to why, or as to how we can use MLFlow in our code. So this is how we can use MLFlow or integrate MLFlow in our model for experiment tracking as well as for a model versioning. Okay, so that's it for this session. I know it's been a long one, but it's been a long one, but with a good purpose. Okay, so once again, I'm very grateful for you taking time to watch these videos. Please again, my request is for you to share with friends. If you are new to this channel, please subscribe to the channel. You can also like the video, comment if you have something to raise, if you want any help with our videos. Please, we are very much happy to hear from you. Okay, so once again, this is the end of this session. The next session, we are going to start with the prediction pipeline. Then we build a web application. So we can build a web application and also using the Streamlit. Also create an application with the Streamlit. See how we can go around with the Streamlit application for the same project. Okay, so that's it. Have a good day. See you in the next one.